All right, welcome back. And now what I'm going to talk about is how to identify horizontal asymptotes. So first of all, we are given the rational function defined a little differently, right? So we have two polynomials here. It says let f be a rational function defined as such. So notice that we have f of x is equal to the polynomial, okay? This polynomial in terms of a, right? The coefficients a. And then another polynomial with coefficients b, okay? So we're just representing f of x as a rational function using different notation, okay? Because what we want to see here, what we want to show you, is that notice that in this case we're denoting that the degree of the polynomial of the numerator is n, right? N, and the degree of the polynomial on the bottom, the denominator, is m, right? Okay. So one thing we want to note is that these degrees may not be the same, right? So m and n may not be equal. Okay, they could be, right? So we're defining it this way for the purpose of defining when we have horizontal an asymptote and what it is. Because again, for the purpose of identification. So we have three cases. The first case is if the degree of n, right, if n is bigger than m. In other words, if the degree of the numerator is bigger than the degree of the denominator, then that means that the function f has no horizontal asymptotes. Okay? So if the degree of the top is bigger than the degree of the bottom, there is no horizontal asymptote. 2, if the degree of the top is less than the degree of the bottom, then the line y equal to 0, in other words, the x-axis, is the horizontal asymptote. Okay? And then 3 is, what about the case that the degrees are the same? Okay? If the degree of the top is equal to the degree of the bottom, then what we do is we take the ratio of the leading coefficients. And that is going to give us the line of the horizontal asymptote. Okay, so in this case, if the degrees of the top and the bottom are the same, then all we do is take the ratio of the leading coefficients, and then y equal to that will be the horizontal asymptote of the graph of f. Okay. And I think that's all you have to remember. Yeah, the other thing too is think about the ratios here. And I'll say this, maybe it comes up in another video, but I think I'm going to say it now. So if we look at the ratio here, since I already have it written out, look what happens to, we've talked about this before. If we consider what happens as x approaches positive or negative infinity, we talked about what is the controlling behavior of the polynomial. And if we look at all the terms, we know that x to the nth power and x to the mth power is going to grow much faster than any of the other terms. So if we're talking about large values of x, okay, well, if we just ignore all the terms on the top and the bottom except for just the leading terms, and we look at, okay, what's going on with these leading terms when we talk about end behavior. And in this case here, as x approaches infinity, right? Let's, positive or negative infinity. What happens if the exponent on top is bigger than the exponent on bottom? In other words, if m is bigger than m. Well, what's happening here? Well, the ratio of these two, what? This top is growing faster than the bottom. And if the top is growing faster than the bottom, then this ratio is getting larger and larger and larger. Whether it's positive or negative, doesn't matter. It's growing to infinity, positive or negative. And so that means, well, if it's growing to, if the function's going off to positive or negative infinity, as x is going to positive or negative infinity, then that means there is no asymptote. Okay? What if the top is bigger than, what if the exponent on top is smaller than the exponent on the bottom? Well, what's happening to this ratio then? Well, if the bottom is growing faster than the top, that means this ratio of the leading terms is what? It's heading towards 0, right? Which is exactly what we say here. The horizontal asymptote is going to be at y equals 0. What if they're the same? Well, again, if we look at the leading terms, if the exponents are the same, then these are growing at the same rate. And, by the way, the x's cancel out, right? So if we just look at everything else, look at this, x to the n and x to the m, if the exponents are the same, they drop out and you're left with the ratio of the leading coefficients, which is exactly what we have here, okay? So again, just think about that end behavior and as it and how it relates to the how the leading coefficient controls the behavior, or not the leading coefficient, the leading term of the numerator and the denominator.